Good afternoon. Hello, everybody. We're gonna talk a bit about high-level protocols. As already indicated by Florian Hartwig yesterday in his presentation, not only the controllers, not only transceivers, but also the first work has started on higher-level protocols. One of them is CANopen in the context of the Canon automation in Nuremberg, and quite a few people involved in this standardization process are actually attending here currently. So it's not just work from Ixxat or my personal, it's Vector and all the other participants in here as well. So the outline of the presentation, I will talk a bit about the motivation for it actually and why we're going to do that, because plenty of people ask now with Ethernet-based or fast networks, faster networks, why would you still use CAN and CANopen? Then we talk about the impact of CANFD on CANopen services. So for which service we actually going to profit really when we talk about CANopen. And just to name them already here, it's going to be PDO services and SDO services. And finally, we're going to have a couple of conclusions and sort of a wish list as we're approaching Christmas. So, motivation. I think in the industrial domain, CANopen continues to be, I'd say, the most popular protocol based on CAN. It's flexible. There are readily available device and application profiles where you can actually use it straight away. And CAN itself offers many advantages for industrial applications. You have, first of all, the event-driven communication scheme. You have the Carasense media access and collision avoidance bus arbitration. You have very low error probability. And actually, last but not least, it's cheap. It's cost effective. So low resource requirements. You can build that on really small microcontrollers. But there are certain limitations of CAN applications where you require really short cycle times. There's a tendency towards Ethernet-based protocols in these applications. For example, drives. Yeah. And CAN has also limits in when you have the need of transferring fast, large data blocks. You heard that yesterday about, I think this was the presentation by Vector, when you have to download, for example, new firmware updates via CAN, it's going to take time, yeah? So there's something there we could really profit. It's not only automotive applications, you have this in knitting machines where you have to download new firmware very, very fast, yeah? There are very strange schemes invented there to speed up download times. So, we have to get around this, and actually CANFD is a very good idea for that. So first of all, you have the speed up of the actual transfer, the higher transmission speeds, and you have the higher payload, where you can actually do things like STO segment transfers, STO block transfers, really to get more data in shorter times over the network. So that's essentially, following the CAN conference last year, Canon Automation started standardization work early, well, basically created first a new special interest group called Application Layer. And the actual standardization work or the discussion on an updated, upgraded CANopen protocol started about early July this year, so not too long ago. And this presentation is going to be basically on the current status of the standardization work. So the work plan of this special interest group application layer is basically one of the things that we did first, actually a clarification of the NMT and the error state machines, which is not at all related to CANFD. So it's not part of this presentation actually. So so don't expect any UML state machine diagrams here and things like that. So the CANopen services that basically we try to identify, we had a look at the PDO services, STO services, and generally other services, protocols where we could really profit from the higher speeds, the higher payload. At the end, there's going to be a couple of new object dictionary entries that we have to introduce very likely, which are related to CANFD, basically because there are some features of CANFD that maybe not that good for CANopen. However, still we take the profits rather than complain about these features. So, and the other requirement was we had a general idea about we should remain sort of the high-level compatibility with the existing implementations. As you could conceive yourself a scenario, and it's not unlikely that it would happen, that you take existing software, protocol stacks, and application software, and just put them on CANFD capable controllers. So you will probably profit from the bitrate switch, but your protocol won't change. So you still have to have, you can consider a mixed scenario where have CANFD controllers overall, but parts of the node in the network will be running just with the traditional CANopen software stacks, and parts of them will be actually CANFD or CANopen FD aware. So let's start with the services that we have there, and actually I start with the system services first because basically you can handle them very quickly. NMT node control, error control, so network management in general, no real improvement with a CANFD. So not touched. So start, stop, reset nodes, node guarding anyway not, but heartbeat is not going to change anything with CANFD. It's going to be slightly faster, but not really. Emergency, similar, but there may be a point where we haven't really discussed if we, for example, extend the emergency messages. Currently, we have 8 bytes available, which is a bit limiting. We have the contents of an error register and an error code in there, and 5 manufacturer-specific bytes, and 5 bytes is a bit limiting to provide decent error information. Yeah? And particularly, some of the device and application profiles use already a couple of those bytes, and they're really limited. So here, if we change something here or enhance this, we will certainly profit a bit from the increased transmission speed, and we will profit from an increased payload that we have available. Time, it's not used anyway very often. You may profit a bit from the increased transmission speed. You have 6 bytes currently that you have to transfer. It's going to go a bit faster. LSS may profit, particularly with the fast scan services, functional improvements possibly. It hasn't started any discussion. There hasn't started any discussion yet. This is anyway not part of the special interest group application layer. This has to be addressed in the task force LSS. So again, it's not going to be part of this presentation here. So now there comes something that I call data services. So PDOs, definitely you have the increased payload available. You get more data in your process data objects. And when you really fill them up, you get the faster transmission speed. Sync, okay, it's related to PDOs in a sense, but you're not going to profit very much from CANFD there. It's slightly faster, depending which version of sync you take, if you take the one without any data byte or with 1 data byte. But here, nothing's going to really change. The big change is going to be here again with the SDO services, because as I mentioned, for example, with firmware download, configuration, download, or things like that, you use SDOs, and there you really would like to speed up things. A lot of applications, startup times for configuration, they are critical. So we focus in this presentation essentially on the PDO services and the SDO services. So let's start with the PDO services and start actually with the PDO mapping parameters. Currently, we have a limitation of at most 64 objects that we can map into one PDO. This is essentially 64 Boolean objects. I come to the issue of Boolean later on. The mapping entries are specified in records in the object dictionary as unsigned 32 parameters, indicating index, subindex, and the length of the application object this is mapped. So currently length, this is 64, so you have here 255, so you could actually map objects of size 255 bits, which you probably won't do. So the general consensus was we leave this thing entirely unchanged. There's no change at all to the existing CANopen specifications. The number of mapping entries we theoretically could increase to a maximum of 253. So 253 application objects within one 64-byte message. makes only really sense if you insist to map sort of Boolean type objects. It's not a good idea anyway. So we have 254 and 255 reserved for basically indicating that the PDO is formatted as a multiplex PDO. So the interest group or special interest group basically concluded we leave that as it is currently, allow for at most 64 objects to be mapped into one PDO. That would correspond to 64 byte objects within one PDO, which perfectly fits the payload size of CANFD. In the same context, we talked about the mapping granularity, and actually initially we tried to get rid of the support for Boolean PDO mapping granularity. Boolean is a bad idea in a sense because it severely impacts performance of protocol stacks. You really have to work with bit shifts all the time, with bit masking all the time. You can do theoretically very, very strange things by having sequences of Boolean and byte and Boolean objects mapped into one PDO. You never can analyze that, certainly not on a hex dump or something like that. So the proposal was to just drop this. Unfortunately, there are some device profiles that first of all allow for optional mapping of mandatory objects, for example the 401. But unfortunately they also, I think it's an application for profile the truck gateway that use Boolean objects in their default PDO mapping. So it comes from the J1939 where they have 2-bit objects and things like that. So the special interest group essentially suggests that we retain the current definitions but really discourage the special interest groups working on device and application profiles to define and use Boolean objects because it makes things more complex. So that's the current state concerning the PDO mapping. A last thing that remains, and that actually was addressed by Heike in his presentation, basically PDO length. Up to now we had really the possibility to do sort of runtime verification if, for example, your configuration that you downloaded into the network is actually correct. So when you expect a 5-byte PDO as a consumer and get only 3-byte PDO from the producer, you will essentially transmit an emergency message. This is not possible anymore, unfortunately, because we have different granularities of the PDO. It works everything fine up to 8 bytes and then 9, 10, 11, 12. But for example, if I have configured on the consumer side a PDO and I expect, let's say, 36 byte, so data content, 36 byte of data content, and the producer will be misconfigured or will be configured such that it only transmits 33 bytes of data content. Basically, what happens on the CANFD level, they both will use a 48-byte frame. Yeah? So you cannot do this runtime detection anymore. So these emergency messages that you use in the CANopen protocol, they essentially become either obsolete or very limited use. Yeah? You could basically just detect, okay, I expect 35 bytes or 36 bytes, and I should get a 48-byte frame. If I get a 32-byte frame, something went wrong. But so there is a limitation there. There was a proposal yesterday morning, essentially, to make it mandatory to introduce the length of the data content in the first byte of the PDO. It hasn't been discussed in the working group yet, so I wouldn't really like to make too many statements on that. But this is an option. But this, again, would be then sort of break backwards compatibility. The other thing is that the configuration or that configuration software in general cannot really assume anymore that you have a maximum data field size of 64 bytes. I currently don't know what future CANFD controllers inside microcontrollers will really support. Will they all support 64 bytes? Will they all only support 32 bytes? Or heard that certain FD controllers will just support 8 bytes. So the configuration software doesn't really know how many objects can be mapped into a message. At runtime, you can address it. There's a certain STO, a board code, when you try to write these mapping tables and write too many data into the mapping tables, which is not supported or cannot. But at runtime, I think it's too late, because then you have done your configuration and you wouldn't like to go back to your office, redo the configuration when you figure out at runtime it doesn't work. So it's much more responsibility for the configuration software there. And this is one of the issues that probably will be addressed by extending the device description. So we will probably need either keywords, additional keywords in device description files, or we will need an extra object in the object dictionary that describes the capabilities of a particular device, which configuration software then could use and basically get the configuration process sorted out in the first place. So this is on the PDOs, I think, and now, yeah, that's the last thing in the communication parameters. Nothing will change. And the only reason why I've put up this table here is because I want to refer to it later when we discuss a feature that we would like to introduce with STO transfers, but which makes STO transfers or makes implementing these features a bit difficult. So that's on PDOs, and now we will look at the service data objects. Service data objects, you know, they are used for configuration, retrieving diagnostics data and things like that, or firmware updates, downloads. We would like to remain compatible with the currently specified services. That was the initial idea. That was a proposal. Initial proposal should be based on the classic STO block transfer. I think it was made by Heinz-Jürgen Oertel last year at the CAN conference at the Hambacher Schloss. Another thing, data transfer should also be possible during the initialization phase, because you have 64 bytes, and when you use only 8 bytes for the initialization or for the setup of the transfer, you have still 56 bytes that you can use to put user data in. Another thing, frame length shall be adapted to the size of application data. Currently, we have an STO transfer always 8 bytes. Particularly with this segment or with the normal segmented transfer, you send 8 bytes, 7 bytes of data, and then basically 8 bytes of no information at all. So you consume bandwidth on the network without actually gaining something. I know of some implementations or some people that use that a bit strangely. They just send 1 byte back, which certainly not conforms to the current CANopen specifications. So, and then this feature here, reading, but respectively writing entire complex objects, so entire structures, should be possible. So one of the features that would simplify, for example, the configuration download, you just write the entire object in one go, without having to address or set up a transfer for each individual sub-entry. The entire thing turned out to be a bit more complex than anticipated. Or basically, everybody thought from the beginning STO is going to be more complex than PDOs. So initial approach or idea was to simply introduce an entirely new service or command specifier, basically command transfer mode, that complements expedited, normal, and block transfer. Well, it doesn't really work, because basically all the command specifiers available, we have 3 bits there in the command word, are already taken. So the last ones, they were given away to the gateway specification. So no chance there. The other thing that we, after a short discussion, decided that not only block transfer should be enhanced, but also the normal segmented transfer. Because basically people were a bit worried that doing block transfer with CAN-FD would put quite a high load on microcontrollers, and they really have to have large buffers to cope with the traffic there, cope with the data coming in. So initial STO design, basically, and that goes back to the history of 18, 19 years ago, something like that. Most of the object dictionary entries have 4 or less bytes, so this results in a requirement for a transfer mode optimized for such objects. It's the expedited transfer. And all SDO transfer modes, at least at the time, should start with a common initialization phase, after which you decide which transfer mode you really use. So you may not be really able to see that from the back, but that's just a depiction of what is currently done for the expedited transfer. You have a data field here and a reserved field here and a couple of bits and command bits. And here your command specifier in the front. So extending this would essentially require significant changes basically to the usage of those bits. I think we all thought that is not really a good idea. So the classically available expedited transfer will remain unchanged. So there's nothing basically that's going to change there. And actually we will try to profit from basically these two bits here, E and S. And the proposed enhancement basically are based on that currently for 3-bit combinations, so E0, expedited 0, and size indicated, expedited 1, size indicated, and expedited 1, not size not indicated, D basically is not available. But for E and S equals 0, the data field here, which you've seen before, is reserved by CIA for future use. So we basically use or propose to use this data field now to indicate that we have a transfer that uses or possibly uses the up to 64 bytes. And this is a current proposal basically of a layout of these 4 bytes that we have there. And the information that you need to introduce there or pack or code into these 4 bytes somehow is if you give your size indication, the number of valid or invalid data bytes depending on how you would like to state it. Because currently, just go back one thing, this field N here contains the number of or indicates the number of bytes in D that do not contain data. So you can count to 3 with N. So we would propose to do it similar here in this thing. And basically, another thing, if you think about the segmented transfer, you need to put in if this is the last segment in the entire transfer or not. If you have size indication in such a scheme, you would enter this into the bytes 8 and to 11, so again up to 4 gigabytes basically possible in bytes 8 to 11 of the CANFD frame. So this already requires that CANFD is not just the bitrate switch, but also uses actually the extended frame format. Yeah, so the entire thing that essentially follows here in the discussion is now only really applicable for CANFD controllers that really do not support just the bitrate switch, the faster speed, but also a higher payload. So the segment protocol, and there actually the big change comes really. Currently we have basically 8 bytes one way, 8 bytes the other way, and do this ping pong scheme all the time. You transfer 16 bytes use or payload, but only have 7 bytes user data. There are plenty of people that don't like that because they are basically, at least in the response frame or one of the frames, 7 bytes are totally unused. So we propose now, as it wouldn't really make sense to send 64 bytes back and 64 bytes forth, yeah, only basically asymmetrical transfers that you have a 2-byte command word, and basically in, for example, when you transfer segment data up to 64 byte. One information that we need in there is essentially something which we call maximum supported frame length. This may be due to basically the controllers itself, but it may be also due to software implementation. But software implementations may prefer, for example, to live with 32-byte frames just because of resource availability, memory availability, buffer availability, and things like that. Yeah. So there's in the frame here, somewhere in there, here, we have this maximum supported frame length. Where they will be exactly located, in which bits and which bytes, hasn't been defined yet. They just have to be there somewhere. So we have here essentially 4 bytes to pack 5 bits of information. So coding hasn't been finally decided. So that's the proposed enhancement for the segment protocol. And now I would come very briefly to the block transfer. And this is largely based on last year's proposals by some enhancements that we made this year. We will use 2 reserved bits in the current initialization phase to indicate essentially 2 things. If we do what we call multiple select, so we would like to address multiple objects at the very same time in one go with one transfer, and as we have now, or we had actually a problem with the CRC, this optional CRC in the block transfer, which is only 16-bit, which is a bit problem when you would like to transfer, let's say, 20 kilobytes for a firmware. We will allow for a 32-bit CRC, optional. Again, here we will need basically to init during the initialization phase the maximum supported frame length by the devices. And I suggest for details you consult either the paper that is in the proceedings or wait a bit. I think in the conclusion I will mention the CIA office is currently writing on the first work draft of the new CANopen 301 specification. So basically the final issue that I'd like to address before I conclude is the multiple object access. I mentioned it in the introduction, first, basically when we put out the requirements. SDOs currently address single objects. So for each single object, you have to set up the transfer, get the response, and do the next objects. So it's a lot of effort, a lot of bus traffic going there. The idea was to allow addressing multiple objects within one transfer. Basically, you use that for downloading configuration data or, for example, retrieving diagnostics information. Would both simplify this. Current status of this multiple object access. We haven't really started actually discussing, or in the group, not only just briefly in the phone conferences, and there had been basically only some early proposals. So what do you have there as a typical scenario? Read an object, and that's why I put up these PDO communication parameter structures just a couple of slides earlier, because that's a very typical scenario. You would like to write the PDO communication parameter structures during the configuration of device. Unfortunately, in this structure, we have first of all entries with different data types. So we don't know per se how long individual entries are without knowing really the composition of the structures. Worse is that not all sub-entries may be actually implemented. For example, for PDO communication parameters, you could very well consider a scenario where you have sub-indices 0, 1, 2, and 5 implemented, but not 3 and 4, or not 6. They're all different data types. So we wouldn't like to set up a complex initialization of phase, basically to retrieve composition of these complex objects that we would like to address, because that really wouldn't make things easier. So a very early proposal that I think has been briefly discussed only on floor to floor, and very briefly in a phone conference, is to use something which is similar to this concise device configuration file stream data format, where you have essentially the number of entries, and then for each entry you give index, subindex, size of the data field in bytes, and then the individual data bytes. When we restrict, and that I think seems to be the tendency, to access only single objects, not multiple objects, but only individual entries or entries within one single object in a complex object, then you could possibly drop the index itself, because you have that in a multiplex as well. But you need definitely a subindex, because you have the possibility or the scenario where you have only subindex 1, 2, and 5 that you would like to write or read. And you need the size and clearly the data bytes. So that's very early. I think this will be discussed in the next meeting and next phone conferences. So conclusions now. As mentioned earlier, the CIA office currently, I hope, is working on the first work draft of what I think we call it currently version 5. If it's going to be a version 5, I think Holger will decide on that. This first work draft, I think, will include the new FSA drawings, being UML drawings. Don't be worried, they're going to be compatible. It's just more clear and more strict in the formulation. And the CANFD-based STO protocols, as mentioned, PDO protocols, nothing will really change. Not yet included, or at least we haven't really discussed that yet, is additional objects that we would need to, for example, indicate what a device can with respect to CANFD in terms of maximum supported frame length and these kind of things. I think on an enhanced error list, error history list, we haven't really found final conclusions either, so I'm not sure if we will introduce that. And clearly, the discussion needs to start, but that's outside of the special interest group application layer, on other communication profiles, such, for example, as LSS particularly LSS will be affected because we have to deal with 2 bit rates now, not only setting 1 bit rate. And device and application profiles, because for device and application profiles, you may want, or probably would like to profit even in default PDO mapping, for example, from the extended payload. So certainly with CANFD as a data link layer, CANopen will continue to be attractive also for more demanding applications. But, and that's the big but, as was presented yesterday morning, I think in the first presentation by Daimler, it's not only high-end applications with 4 core processors that will integrate or require CANFD controllers, but also small sensors. Yeah? So even a car, you have small sensors, and particularly in industrial applications, you need actually low-cost microcontrollers with a integrated CANFD. Yeah? And we are just waiting to get them. This conference, I think, has been much focused on automotive, but there's also an industrial market, and they would like to see, and we would like to see here CANFD-capable microcontrollers as well. Certainly, it's also in the interest of the special interest group to perform some prototype implementations before we actually finally publish this document, because you would like to see if what the proposals that we have put up to now really will work. So it leaves me for the acknowledgements. First of all, thanks to the CANopen Automation Office for their help during the standardization process, because they have to write it down. And clearly also to the members of the special interest group application there, and last but not least to the colleagues at Ixxat for the discussions. And last but not least, to the audience. Thank you.